Hello, everyone. My name is Moshe Naveh, and I'm from the SAP community team. Welcome to the SAP community call about Boost Your Cloud Foundry Edit, Build, Test, Debug Speed by Andrew Lunde, a SAP Technology Ambassador and a Senior Solution Architect for ISV Partner Enablement. Andrew, take it away.
All right, great, Moshe. Thanks for inviting me out to speak today. So, welcome to this call. And again, my name is Andrew Lunde. I work with a partner enablement team. It's part of the Partner Edge program. And we help strategic partners build solutions for various markets. And so got a decent bit of experience in building SAP cloud applications, started with HANA stuff and kind of graduated into the cloud. So what this talk is about is largely, it's largely some of the best practices and tips that I've kind of discovered throughout my experience here doing this. So we're gonna take a look here. So here's the agenda for today's talk. And the other thing I'd like to make sure is to invite the audience. If you've got a question, we've got Moshe, he's moderating here, and we'll be looking out for questions. If you have any, as I go through the discussion, please feel free just to ask them at that time. I'll have a section at the end of the talk to answer any questions that you might have. But it tends to be a better discussion if you just ask them when you have them. And that way we can kind of discuss them in context as opposed to trying to loop back at the end. So again, if you have anything that you'd like to ask, just stick it in the question dialogue and we'll try to get it asked. And if I can do that, that would be great. So anyway, here's the agenda for today's talk. Originally, I spoke and presented this at the Cloud Foundry Summit last month, early part of last month. And the content, I had 30 minutes to present this. So I was a little rushed. I don't have a lot on my slides. I tend to talk to just a few bullet points and images, and we'll kind of dive into some of the tools as well as command line. So it won't be all just boring slides. So let's get started. All right, the root cause. So why are we even having this talk? Well, when you're working with any environment and doing development, it takes time to, especially when you're working with compiled languages, it takes time to compile your code and then execute it so that you can see what it's doing. If it's all local, things aren't too bad. And if you're using an interpreted language like JavaScript or Python or something like that, PHP maybe, you can make a change and quickly see pretty easily what the effects of your change were. And when you start moving into a cloud environment, this becomes a little more difficult because your code is not actually running on your local machine. It's now getting sent to the cloud in order to execute. And the environment there is different. And the time it takes to move everything there and get it running and test it is pretty considerable. And we're going to get into that in a minute. So I'll be able to kind of show you some of the tricks here, but that's effectively what we're talking about. All right. So the type of development that we're focusing on today is microservices application development. Now, SAP has a strategy for doing microservices development, and we have ways for running these type of applications on-premise systems, and I do a lot of that as well. And some of the hints that I come out of this talk came from some of those efforts. But in the cloud is definitely where a lot of microservices development is targeted. And if you do any sort of microservices development, you'll quickly come up to this 12-factor app methodology. I'm not going to get into it at this moment, but if you go to 12factor.net, you'll see there's just kind of a whole philosophy and methodology behind this type of development. And we're going to take advantage of some of these sort of key things. But most point number 8 on that list of 12 factors is concurrency, meaning that that your application runs kind of in components in an isolated environment. So we're going to see what that means here. And another thing that SAP introduces on top of just microservices development is the concept of multi-target applications. So depending on if you're doing sort of non-SAP cloud development versus SAP cloud development, you may or may not run into this concept, but it is very centric to how SAP does its development. And it separates your once monolithic application into a lot of smaller ones. And the multi-target application metaphor gives a set of things a common life cycle so that you can version control and deploy them as a unit. So let's look at a typical one. So typically, the first point of your application is what we call an app router. So this is another assumption is that all the communication is through HTTP-esque style communication. So a request coming into the app router is going to be an HTTP request. And that app router may or may not serve like static files back to the user. So a good example of this is the fave icon that the Chrome browser wants to grab off the root path just to show your little icon in its toolbar. So it's nice to have something that can just quickly serve static files. Another thing that's a key role of the app router is the authorization and authentication functions, which it interacts with the Cloud Foundry service for that. So after your request hits that, if it needs to do something a little more sophisticated, typically we engage another module. We call these worker modules just for simplicity, and they can be written in a variety of different languages. So where the app router might have been implemented in Node.js, maybe you have a worker module that's in Java to do some calculation, maybe connect to some outside sources, maybe do some database connection, doesn't matter. So typically you have more than one. Don't have to, but you can have as many as you need. And one of the beauties of this approach is that you're not restricted to having your whole application written in the same language. So here I'm showing another worker that's perhaps written in Python, and that's fine. Other languages we support, Node.js, of course, Java and Python are kind of the primary ones, but you're not even limited to those. You can use other languages as well. So another thing to consider in the methodology is how SAP does database, how it instantiates database artifacts. So if your application needs a database of some sort, HANA is the one that we like to use, then you need a way to get that database built up, the schema, the objects created. And in order to kind of keep all that together in the source control, the methodology SAP uses called HDI, or HANA Database Interchange. This allows us to keep the source code that creates the database objects in our project as well. And then we run a little project, a little component called the DB Builder that takes those files and creates a data container. So the thing about this DB Builder is it just runs and then it ends. And another thing to note is that it reads an existing container and compares things. So it does, if you make changes, add a column, add a new table, it doesn't necessarily rebuild everything from scratch, especially if you have data already in there. You don't want it to maybe be destroyed. So, but it's important to know that this is just yet another module that runs and does some work for you and then ends. So all these boxes, other than the data container, it's important to remember that each one of these in its own right represents a full web server. Each one of these can field requests. And while you're building things, it's important to also to remember that you can kind of test these individually. You don't have to always send requests through the app router. You can test them in isolation, and that's something we're going to touch on. So once the builder does its thing, then the data containers is created. The builder can go away, and then the worker modules connect to the data container, and then they might each interface differently. So a good reason we might want to use Python is to do like some machine learning tasks against the data, etc. So anyway, one of the things to keep in mind, as I mentioned here, that each of these boxes are full web servers. So one of the things that has to happen to get these deployed and into the cloud environment is, if we look at a timeline here, first off, we have to, when we're building and assembling, we have to get dependencies, various libraries, etc. Then we have to take the time to assemble them together. Then that package of things has to be uploaded into the cloud. And then when it starts running on the cloud, the system has to create a container. This takes time. It has to pull in a build pack for the language that your container's using, your module. Then there's another opportunity to get more dependencies depending on how the build pack is configured and whether all the stuff you supplied is sufficient to get your module working. And then internal to the system, it creates what's called the droplet, which is really just a little storage inside the cloud. And it stores everything there, ready to go, and then immediately reads it back out of storage and creates a singular instance of your application. And this is one of the things that is a big advantage to this style of programming, is that maybe you just need one instance to kind of test and see how things are going, but when you're running in production, you might need several instances to kind of spread out the workload. Again, all these connections are HTTP between these modules, and in that way, if there's several of any of them, it just round robin dispatches the requests. And then you get into the running and monitoring phase, where you then can finally see what's going on. Well, all of these things take time, and that if you want to make a change to your code and see what happened, and you have to run through all these steps, then it gets to be pretty long development cycle. And that's one of the things we want to address here. One of the things that we can do to kind of bring it back home is localizing our development environment. So here we are looking at our application again. One of the things you can do is you can use and try to test your application as much as possible locally before you even try to deploy it into the cloud. So in this case, I'm going to focus on this Python application, and I'm going to use Eclipse as the basis as my IDE. Now, again, keep in mind that it doesn't have to be Python. It doesn't have to be Eclipse. The same principles apply. If you do a lot of your work in coding locally, then it's very fast just by nature. So let's go flip over to Eclipse. Here's my project in Eclipse. I'm looking at the main Python server code, which is actually, this very simple example is actually all the code is in one place. In my code, I have several routes. These are the paths after the slash. So for instance, I mentioned here the favorite icon here. I'm just statically serving it from images. That's local. And so anyway, one thing I can do is say, as much as I can work through all my code and build it here. Now, I can take advantage of, for instance, the fact that Python is white space dependent. So the editor knows how to deal with a white space, so it can help me from making mistakes there, indentation, etc. You can see here they're doing code coloring. That's nice. But the biggest thing is, like, if I make a change quickly and I want to check it out, what do I do? Well, I can just what I want to do is I want to pretend that my code is already deployed. And in order to do that in Eclipse, you can create what's called a run profile. So here I can say run as the Python module itself. But one thing I want to show you before I do that is the run configurations. So I've set up a configuration. I won't get into all the detail. It's using a local version of Python that matches what's in the cloud environment. So I'm going to, that's always nice to kind of keep the whatever the version locally is matching where your target environment is. And this thing doesn't require any arguments, but one thing I did want to point out is environment. So again, going back to the initial microservices architecture strategy, the code is designed to pull in from its environment and the information it needs in order to do its job. So one of the things that it expects is a variable in its environment called port. This is what the system is telling it to bind to in terms of its HTTP server. So here it's specified as 8089. It doesn't really matter what it is as long as it's not being used locally. And then the application itself expects this JSON structure in an environment variable called vcap services. So here it looks like it's just a little bracket, but if I go and edit it, you can see here it's actually quite a few lines of stuff. Now this is the information about how to connect to the HANA database server and credentials and stuff. This is stuff that was generated by that deploy process, that HDI deploy process that I mentioned earlier. So by providing that in this localized environment, the application itself doesn't know that it's running local or remote. As long as it can get to those endpoints, then we can test it pretty effectively locally. So this is a nice little trick. I'm gonna close this. So here I've already stopped it. Let me clear the window, but I can let's just run this quickly. I'm going to go run as Python run. So it's asking me to save my file there. Okay, so we can see here that it is actually running, and it's running on that port that we asked it to, localhost port 8089. So it says it's running. So we can go to a browser, and we can see here on that localhost 8089. Now I'm going to refresh the screen, and we see, sure enough, it put together some links. Now I can go back and forth and test these things. I'm going to, for instance, look at the environment. Again, we can see that structure I just looked at is indeed available to it. Here's, let's go back a bit. I can test some things. Here's a different path. It's similar looking links, but you can see here that now I'm checking a different path in the server. So I can, for instance, if I wanted to make a change here, I could go to the Python links route in my application. Maybe I'll change that so I can stop. I can quickly go back here. Let's see the Python links. You're going to say, hello world. Let me put a couple exclamation points here and save it and stop. Oh, actually, because I have this Python module set up to notice whether or not a change has been made. In fact, if I go down to the bottom, I'll show you this quickly. Python has a certain mode called debug. And what that means is that it runs its own little debugger process, and it notices if something has changed. So just the mere fact that I save the file means that it's changed and reloaded itself. So if I go back to my browser and just hit reload, boom, that change is immediately available. So that's quick. That's nice. But you have to understand that you can't do everything here. Some of the things I can't do very easily here is I can't test the authorization stamp paths, things like that. If the database isn't available locally, or remotely from my local machine, I might not be able to test the database functionality. And if I need to kind of show interactions between my modules, I can't do that either. But that doesn't mean I can't get a lot of coding done. When you're in the initial phases of development, you make a lot of mistakes. You forget, was it plus? Was it plus a concatenation character in strings in Python? I can't remember. Or was it dot? So it allows you to quickly make changes, get all the functionality worked out, and move quickly prior to actually having to deploy something. So let me go back to my slide and see if I'm missing anything. So again, work locally as long as you can. Again, the response is very quick. Again, you can't really test the authorization. So set things up for anonymous first. Mimic the deployed environment like I did with the environment variables. And then if you have to make changes and then test it from various things, use git control so that you can kind of push and pull from various places. So what's tricky about this? Is the data container available? So this is, oops, sorry. So this is the question of, is the database available? It may or may not be, or you might run it locally if necessary. But you can only really go so far. I mean, there are other services that are typically available in the cloud that are not going to be necessarily available locally, or they're not going to be very easy to replicate locally. So for instance, if your application is like binding to a data lake or something, you may or may not be able to like implement a whole Hadoop cluster locally or something like that. So, so this approach only does take you so far, and you're really going to want to develop in and deploy and test in the actual deployed environment to really see how it's working eventually. So again, in this case, what I was doing was testing localizing, but and again, the local, assuming is local Python can get to the data. All right. So what if that's not possible, or you need some? You actually need to test it as it's deployed in the cloud. Well, you can do, and this is my own term, what I call piecemeal deployments or pushing. So normally, when you get your application sent to the cloud, you're doing what's called a deploy, which is that whole set of components at once. And that I'm not going to go through it here, but if you look in the Git repo for the project, you'll see some notes that I use, and the time it takes to push. Just flip over to this quickly. I look at some of my notes in the repo, and this is on GitHub, by the way, if you want to use this repo. But some of the things is that the whole pushing, building of the bundle, getting the repo, getting all the dependencies and pushing it and deploying it. In one case, I was timing it took 460 seconds. Well, that's like 8 minutes, right? So that's a long time between testing things. So one of the things you can do is you can what I call, and we went through localizing things. And one things you can do is instead of doing the whole thing is just push part of it. So if we use the push command, cf push, we can push just the Python component, not all three of them, as I described. It's perfectly fine. And when you do this, I'm wrapping this in a little script so that I can see how much time it took. But when you do this, it takes much less time, because you're literally sending, like a quarter of the data to the back end, to the cloud, than you would normally. So in this case, I did a little timing test, and it took 81 seconds. So okay, great. It's a little over a minute. If you have to go get your coffee or something refilled, maybe that's not such a bad thing. You just make a change, and then you can start testing it in the cloud. Well, that's still pretty long, right? So it's what else could we do to kind of tighten things up and make it a little speedier? I'm not going to go through and show you this working, but effectively, it makes it. It cuts down the time quite a bit. So let's flip back to the slides here. So here's a scenario again. Our local workstations are here. This is our application deployed. Okay, so this now requires it already to be there. And then, so now you're doing a push action and you're actually sending the whole copy of this module into the back end, into the cloud, and it restarts it and rebuilds it and redeploys it locally. But since you're only doing one, and we're not doing that DB module either, it's a lot smaller. But let's see. So again, some of the points about this, it still takes some time. You don't have to rebind anything. So like this binding here to the data still remains. And you have to make sure that that the information about when you send it is manually sent along with, since you're kind of manually putting one component. So you might have to use some of these parameters. And one of the things you have to be aware of is that if you're building this, for this instance, this Python module locally, and your architecture is not the same as the system you're deploying to. So in the cloud, it's typically a Linux system. Locally, you may not be using a Linux system. So you either have to emulate that or be sure, absolutely sure that you're including dependencies that are the architecture for the target environment. And if you're not careful about this, it's easy to mix this stuff up. You'll end up pushing something into the cloud that doesn't work. One of the ways I use to get around this is to use a Linux Docker module to actually emulate Linux locally. That way I can be sure, and then do all my building and stuff, packaging there. That way I'm sure I get the exact same architecture as the end result. All right, so what else can we do? So there's what we call editing and testing after deploy. So in this scenario, here we have our local Python code, and we want to just, because Python's an interpreted language, we don't have to compile it. We just have to move, if it's possible, we can just move the source code files into the deployed container. So here we have the local source. So in this scenario, you just, you edit, you can either shell into the deployed container and then edit the files directly and see what's happening. But if you do that, there's some problems. One, if you cause your program to fault, it will reload from the blob store. In that timeline video, you might remember that little sending it into that little container and back. That's the blob store. If it faults, the system will realize that it's not responding anymore, and it will relaunch it from the blob store, and any changes you've made will be lost. So that's not good. But there's a little bit better solution to use, which is keeping your local files local, and then make a change to your local file, and then send it into just that one file into the already deployed. So copy it into the live container. So you're testing it in the deployed environment, but you're making your edits here in the local environment. So you're effectively using SSH to copy into there. So let's go back and let's look at that situation a little bit. Going back to, so this is Eclipse, and what I'm going to do, so this is on my local machine, but I've got, as I mentioned, I've got a Linux container, and I'm going to make sure that this is actually in a different set of files. So again, if you're making changes, you need to use Git to kind of move things and synchronize them. back and forth. But what I can do is I can use a little script I wrote. If you get this repo, you'll see there's a folder called Tools. And in the Tools, there will be a couple handy little scripts, and one is for creating and the different components manually, setting the environment for doing JSON stuff. But there's another script here, CP2CF, which means copy to Cloud Foundry. And this script uses this mechanism that I'm going to describe in a second to go and to copy a local file directly into the deployed container. So first off, I'm going to go back here. I'll use my CF command. Let's look at the applications that are deployed. So here we see there's that database module. It's in a stopped state. It's already done its work. So I got these three running. That the main app router, the Python one that we're kind of focused on right now, and the Node.js. So as you might notice, they each have their own URLs. Again, you can test these things independently, but let's just focus on the Python one right now. So if I go and take this Python URL, I can browse to it, and here we are. So what we can do is CF has an SSH subcommand, which uses the underlying SSH scenario, but it does it in a special way, and I'll get to the tricky part in a second. So I'm going to shell into the container that's my Python. Okay, you see the prompt change. Now, go back to my image. Now I'm actually shelled into the deployed Python. So let's see. So if I do an ls here, there's all the dependencies for the application and then some system stuff. My application actually resides in this app folder. Again, this is as it's deployed. So I'm going to go into that folder. Here we are. We can see everything that we expect to see in our Python stuff. So again, this is just the container for the Python stuff, but here's our server file. And as you can see here, it's the same set of files. So I'm going to edit that server file. And let's go to where it says hello. So here's the root hello, the root path for the hello. And I'm going to say hello world and maybe use some dollars or pound signs here. So I'm in VI here. Remember, I'm shelled in, so my use of the available editors or whatever happens to be in that shell, VI happens to be there. I'm going to write that file. Now over here, I've got a little console that is watching the logs of my application, and we can see here that it just spit out that it's restarted itself, and it's actually taken that, it says it detected a change in the server Python file and it's reloaded itself. So let's go back to our browser and let's reload this page. And sure enough, here's that change I just made. So boom, all day long, I can sit here and I can change this to, at signs or something like that. Control, write the file, it gets reloaded. Just reload the browser. You can see the request coming in. Sure enough, here's my changes. So that's pretty quick. But again, the downside of this approach is that if I do something that causes it to fault, maybe I don't indent something right, maybe I miss a colon, something that causes it to fault, then anything that I've changed will be lost. So again, that's where this other approach comes in. So I'm going to quit out of this app. I'm going to exit back from my shell back to my local machine. All right. And now, so I have it locally, and I'm going to set up to do this. So hang on for a second while I look in my notes. Again, this is in the project. So we went through the editing. All right. So a few things you have to do with Cloud Foundry to be able to even shell into it is you have to run this enable SSH command, and then you have to, and this is really important, easy to forget, you have to do a restart on your module, otherwise it won't work. If you can do this, CFSSH into your module, then things are good. So, and then we already did this. I changed into the app folder and then made an edit. So the next thing you can do is you can run the SSH command, the normal one, in a special way that attaches to a special endpoint on the Cloud Foundry environment. And when I discovered this is a pretty cool thing. And it requires that you do this thing called getting a one-time code. And this command gives you that code. And then you're allowed to shell in. This long, crazy string is actually the GUID of your application's instance. And you have to use this formula of CF colon and then that GUID. And then this /0 means this is the 0th instance of your application. Again, you can have several running, so you might have to say /1 or 2, depending which one you want to connect to. You need to connect using this special host name. And if you do this all correctly, it should work. So I'm going to go back here and let's just do it. So, so I chain these things together so I can spit out that special code, and then I using SSH to connect, and it's saying, hey, put it to, and it's asking the known hosts, and then it's asking for the for a password. So it's actually asking for this secret one-time password, and I just pasted it. You won't see that, but boom, here we are back. We've shelled in. There's my app folder again, and our server, sorry, Python, it's there. Okay, very good. Let's exit back. All right. But what about moving the file? Remember, this was what we were after. We're after being able to copy the file from locally into the remote. So let's go back here. All right. So what I need to do is look at, I can change into my Python folder, do some change, and then actually invoke this command, which is using that. It's taking that special code and it's shoving it in a little temporary file. And this script knows how to pick up that file. So I'm going to do these commands. Oops. So first I'm going to get into my Python folder. And then I'm going to edit the server file and do a change, see what change we can. So let's go to the hello stuff. All right, so this is, again, this is the root path for this. So remember, this is on my local machine. So I'll change hello to like yo. Okay, I'm gonna save that. Again, this is local, so I'm gonna quit out. And then I'm going to run this command, which basically picks up that one file and sends it. So there you go. Bad interpreter, message file or directory. Hang on. Did I not? Well, I think it's since I last here's my script, and And it's set to execute. I may have maybe running the program from the wrong place. Okay. That GUID file. All right. If this isn't going to work, I'm not going to press on it too much. We've got about 20 minutes left to talk. But the point here is that that little script just moves the file. And it uses a tool called expect, and I neglected to install it in this container. I apologize for that, folks. All right. This inspect tool is designed. It allows you to kind of enter a password where it would normally only allow you to enter it manually to do it. But let me just at least this. Let's look at the tools. Script here, just to show you that there's not much going on here. Effectively, what it does is it runs that command SCP, which is a secure copy, which is a variation of the SSH command, and it does it in a way that uses that special file format to connect to the user, to the system, to your container, and then it moves the file that was specified into that VCAP app position. So again, apologize for this is not. I should have tested this a little more before getting on the call, but hey, this is how things go sometimes. Effectively, though, it does move it to the server. So let's continue on with our discussion. So again, just copies. Basically, it just automates this copy process. So what's good about this is that you can edit on the local machine and then copy it. So kind of just rerun that command every time you make a change, and then you can test just as quickly. And then, if you do something that totally messes it up, you haven't lost all your changes. This could be a good way to discover what's necessary that only works in the deployed environment. All right. So last but not least, tunneling home. Okay. There's times when you really want to debug and execute some code that is already deployed in the environment. There's no way for you to locally replicate the environment that's presented in the deployed environment. You really need to debug it here. Now, we've been debugging it by, if you can look at the logs and you can spit out some values to the logs and watch what's going on and make changes, try things out, maybe echo statements, various values of variables in your code, that can go a long way. But at the end of the day, it's just still not true debugging. And so what else can you do? Well, there's one more thing I'm aware of, and that is you can actually set up your code with a debug client and set up your local machine as a debug server and create a connection between them. So in this case, the trick about it is to use what's called a reverse SSH tunnel. This allows, since the direction of the connection is from the cloud to your local machine, it doesn't know where your local machine is. In fact, you're probably behind network address translation on your local network. You might be firewalls in the way. Your local machine doesn't have its own IP address. So there's no way for that module running in the cloud to know how to get to your machine. However, even though the direction of the debug connection is this way, you establish this in the same way you've been doing it in our other examples. You actually use SSH command in a way that allows you to shell into it. Once this is established, you can set up your code to call a server. It thinks that these two places are effectively on the same network, and you can run a server here, and then you can then step trace and inspect everything, and look at variables and change code, all running live. So that's great, and that's kind of what is the holy grail of being able to debug. But the downside is it's really tricky to set up. The code's got to be set up to kind of reach back to the server. So you need some code that you can execute that initiates this connection. The source code in both places has to completely match, and that's also really tricky. These things need to be mapped to each other such that when you're running source code and stepping through it on the server as it's deployed, it's got to see the same exact source code on your local machine so that it can present it graphically so you can see what's going on. The tunnel sometimes can drop, so you have to be aware of that and reconnect it as you have opportunity if you see it fall. So you kind of got to keep an eye on that. And then you really want to remove that code that makes this reverse connection back to your local machine prior to doing any real production deploys. This is really only designed for the most in-depth debugging sort of scenarios. So once again, I'm going to jump back to Eclipse. I'll show you a little bit of this. Here we go. This was running locally, so I'm going to stop that. And let's go back to my notes here again in the GitHub repo. Here we have the long variation of this code. Now, let me show you a few things about it. So if you're following along and trying some of these things, you'll notice the same pattern exists. This is the special endpoint to connect to that you can use with various tools. In this case, I'm using SSH. I have to get that special code again because it's going to prompt me for it. But I'm passing it some parameters here that means don't start a local terminal window, just do it in the background. I'm using this port to kind of facilitate getting things set up. But the most important thing is this -R. That stands for reverse. You might see this command using -L. If you use -L, same thing happens, but the direction of this arrow is reversed. You can only then call that direction, not this direction. And since we want this to be the client and the local to be the server, we need to have the connection directed this way. So that's the R. Now, this particular Python debug server is by default runs on this port 5678. I want to map the local and the remote both to the same port, so that way it assumes that when anything gets connected on this port, it'll send it to the other side as well. And once you got the tunnel set up, then, and here's some details about how to test it, make sure it's working. Once you have it set up, then you need to do some things to map the folders so that they replicate and they look the same. I'm not going to get into this. There's some tricks about doing it, but I just want to show what needs to happen on the client side. So since I'm using Eclipse, and this will depend on what IDE you're using and what language you're using. You have to, once this tunnel's set up, let me go back to my Eclipse. Eclipse has a function for running. I have to go into the Eclipse debugging mode. And then I can start a debug server locally. So notice that now the little message says, hey, it's now listening on this port locally, but since that the local environment is tunneled to the remote environment, anything that happens in one place happens in the other. So effectively, it can communicate back and forth. So I'm running a little low on time, and I wanted to leave some time for questions if there was any. But so I'll just show a few things. You can do all the debugging sort of things you're typically able to do, set breakpoints. Well, let's see if we can just get this tunnel set up. I'm gonna grab the tunnel. And so this is actually in my shell, my Docker shell, so that won't work. I need to have it into my local machine. So again, it needs that special one-time password. All right, now it's not doing anything, but one thing you might notice here in my log window, it says, oh, now the remote has successfully connected to its debugging port. So that means I'm connected from two places. And if I go and exercise the code, so let's go and just click on this link. Notice that it sent some information to the debugger. And if I go back to my debug window, it should, let's see. Oh, I actually have to hit a little endpoint. So these, remember I mentioned set mapping things. That's what these links do. And then once that hits the point in my code that actually reaches back out, it's called this attach endpoint. So notice here, I'm getting logs, and it should have connected. So let's go check back here. And sure enough, a debug session did start. And we can see here that it's attached to the debugger, and sure enough. So let's now go and run that exploit. So here we see that I've now exercised the application. It's come and connected, and here we are. It's running. It's is now stopped at this endpoint. Now it dropped, which does sometimes happen, but let's try it again. Let's see. Here it comes. Anyway, once it's connected, you can then step trace through, do all the same typical debug commands. You can inspect variables, etc. So anyway, let's just wrap it up here since we're running short on time. So any questions? I have in the deck, which we can distribute, some links to my project and some of the blog posts that I put out that relate to this. But for this point, I wanted to open up the floor for any questions. Moshe, any questions that arised?
No, I think we're good so far.
Okay, very good. So with that, I'm going to close. So I want to thank all of you for attending this session. Again, my name is Andrew Lunde. I'm based in the U.S. on the East Coast in Atlanta. I'm happy to be a SAP Technology Ambassador to kind of help spread the word, what SAP can do. And if you're indeed a partner and are part of the Partner Edge program, there's a good chance that we may run into each other as I help support your efforts to get SAP solutions built, put in the cloud, and making you some money. So with that, I'll close out. If you wanted to have any last words, Moshe?
No, I just want to thank you for a great and enriching and interesting SAP community call. I will stop the recording now. Thank you, everyone. Bye bye.